Parvasivam.
Hello, sir.
Yeah, we can wait few more minutes or we can start. What's your
Yes, sir.
opinion?
Students has to join, no? Some students at least. How many
Unite-
joined
unite-
in ADS?
200 students are joined. 197.
Okay. Yeah, I think now 4.02. We'll start within a minute, sir.
Yeah.
Sir, you start, then share my screen for inauguration,
Okay.
sir. First you start, sir.
Welcome all to the guest lecture series, and here is our first guest lecture, and the HOD of chemistry department will give a welcome speech, and he will give a introduction to the course, how we are planning for this course. So I will welcome HOD for the welcome speech.
Greetings of the day. For us, it's good evening. Welcome to the guest lecture series for Environmental Studies course. Today, we are going to start the lecture the very first time. I am welcoming on behalf of our IIT AP University, Department of Chemistry and the School of Science and Languages for this online guest lecture series. This course, CHY 1001 Environmental Studies, is having two components. First one, invited expert guest lectures based studies, learning process, followed by project work in the laboratory after some time. For this course, we are starting the lecture series, weekly one lecture like that. Today we are having our guest speaker, Dr. Balakrishna Prasad. Sir, he did his MTech in Environmental Science and Technology, JNTU, Hyderabad, and did his PhD in Ecosystem Science and Aquatic Chemistry, JNU, New Delhi, and he worked as assistant professor for a year in the Environmental Science Department in University of Hyderabad. During his research studies, he had excellent fellowships in Uppsala University, Sweden, then GKSS School of Environmental Research in Germany, and AG Research Fellowship USA like that. His research areas broadly varies from marine ecology, hydrogeochemistry, sediment chemistry, heavy metal pollution, and biogeochemistry, among so many others. In fact, he is having a lot of publications, more than about 335 research journal publications in reputed journals and 4 textbooks also. In fact, he worked a lot in especially aquatic system from Kerala side to Himalayan regions, especially for aquatic, river birds, so many aspects like that. Now, sir is working as scientist in Earth Science Systems Interdisciplinary Center, University of Maryland, College Park, USA. Currently, sir is working on an interdisciplinary research project on developing an integrated modeling system to predict meteorological and ecological parameters of the Chesapeake Bay, the area, Maryland area. So SAR is having vast, excellent experience in the environmental science. Now, I request our fresher students to listen the lecture carefully and try to grasp the subject, understand the basic ideas from the lecture. After the lecture, we may have some evaluation process like some quiz like that for to understand your level of understanding. Right. Today's lecture topic, sir is going to deliver on environment and ecosystems. There you may have some idea regarding composition of earth and atmospheric aspects, life support systems and ecosystem services. Now I would like to thank everyone, our coordinators and our institute people to arrange all these things. And finally, or foremost, I'm really thankful to our guest speaker, Dr. Balakrishna Prasad sir, for accepting our invitation under a lot of constraints under this pandemic situation, and he is ready to present his experience and knowledge sharing for you young people. Please try to listen carefully and understand. I request the students once again. Thank you, sir.
Yeah.
Speaker sir, I think now you can start your lecture, sir. I'm handing over the dais to you, sir. Thank you, sir. Welcome, sir, once again.
Yeah.
Thank you, sir.
Yeah. Thank you so much, and it was so generous introduction, and I highly appreciate that. Please let me know if you are able to hear me. If
Yes,
I
sir.
need to adjust. Okay, fantastic. Okay.
Okay, sir. Sabil sir, you have to share his screen, sir.
I'm sharing my screen.
Yes, sir.
Okay. Can you see my screen, please?
Yes, sir.
Okay.
Yes, able to see, sir.
Sure. It's a good afternoon to all VIT Andhra Pradesh chemistry students, and I think the student composition may be from across all disciplines in the engineering stream, starting from computer science to civil engineering and other areas, I guess. The topic that I'm going to talk today is ecosystem ecology, perturbations from global climate change and human activities. And as Dr. Paramasivam, HOD said, yeah, I'm from Andhra and I did my master's and master's and bachelor's from Andhra, and then I moved to Delhi for my PhD in Jawaharlal Nehru University. Then I worked in University of Hyderabad for a while as a faculty, and then I moved to University of Maryland College Park for doing research activities on the ecosystem ecology and environmental modeling. And then I worked in a law firm as a scientific advisor, and finally, currently I'm working for federal government as a consultant, scientific consultant. Okay, so today my topic broadly includes introduction to earth and ecosystem science, and it includes ecosystem structure, earth system, biogeosphere, and critical zone, and ecotones, and basic understanding about biogeochemical cycles. And next one, the third one is human impacts on coastal ecosystems. Here I'm taking a couple of case studies, one from India and another is from USA. India is from Pichavaram Mangroves, Tamil Nadu, and the second one is the Chesapeake Bay, which is lying on the east coast of US. Okay. So biogeosphere. So what is biogeosphere? Biogeosphere is an integrated, complex Earth ecosystem. It includes a combination of interactions starting from ocean, atmosphere, and the space, all three components at the same time, including the geosphere as well. All these four components are integratedly interacted with each other in terms of movement of the energy, movement of the transportation of metals, including trace metals and then heavy metals across all these three interfaces in order to maintain the equilibrium. So therefore, the biogeosphere is a very complex Earth ecosystem. As I said here, it is a major four components. One is the geosphere, atmosphere, hydrosphere, and biosphere. So biogeosphere means it is a combination of the three elements, geo, atmosphere, and hydrosphere, which contains that biogeosphere contains the life sustaining mechanism to support all sorts of biological activities, starting from microbes to the multicellular organisms like the humans. So the biogeosphere is very, very critical for life sustaining, and it is the major component in the Earth system that supports the energy flow and material flow and energy transportation and all sorts of ecological variable transportation mechanisms. So if you come to the next slide, here you see that biogeosphere. Here you have the forest ecosystem is a soil ecosystem, and this is a volcano, and atmosphere and hydrosphere. So this biogeosphere is the combination of all these four elements. And as I said earlier, most of the life sustaining processes on the earth particularly exist on in a narrow band which is very, very close to the surface of the planet, so which is known as the critical zone. The critical zone is the very, very narrow band very close to the earth's surface. That critical zone is a heterogeneous environment, near surface environment in which the complex biogeochemical or geochemical interactions, those interactions involving rock, soil, water, air, and living organisms that regulate the natural habitat and determines the availability of life sustaining processes. you know so an array of important physical, chemical, and biological processes and reactions occurs within this critical zone over a period of near time ranges and also the long term ranges. Near term ranges in the sense it is a within a within hours to a few months, and a long term means 1 year to few years. So these temporal scales, this happens, and these processes impact the mass and energy exchange necessary for biomass production, chemical recycling, and water storage. So they also control the transport of and transporting and cycling of contaminants and nutrients that have a critical effect on soil, water, and air quality. So the activities that are happening within the critical zone is very, very important to study in order to evaluate these impacts on human health and the sustainability of ecosystems and its inhabitants. So therefore, in the recent times, an extensive studies have been happening in order to understand the ecological dynamics along the critical zone environments, to study the human impacts and climate change impacts on this critical zone, because a huge amount of population density is distributed along the critical zone. Here I would like to give one example that if you look at the coastal areas, either in India or US, for example, Chennai City. Chennai City is lying on the east coast of India, and the capital city of Andhra, and also Andhra Pradesh has a very long coastline. So all the big cities lying on the coastline, like starting from Kolkata to Bhubaneswar, then Andhra Pradesh and Tamil Nadu, and also the Kerala, Chennai and Trivandrum and other areas. So what is the reason for this huge population density along the coastal areas? Because of revenue, because of money generation. So the coastal area supports the human development and also the civilization. So therefore, those are the very attractive areas for human settlements for various reasons. And at the same time, there is a huge stress on these critical zones. So if you make a pressure on these zones quite extensively, then there will be a lot of negative impacts will happen on those ecosystems, and that will disturb the ecological equilibrium, and that ultimately affects the human um, uh, human sustainable development along the critical zone. Therefore, we have to be very careful when we are dealing with these critical zones. Therefore, we have to develop and understand the ecosystem dynamics and the basic fundamental dynamics, and we have to use that fundamental dynamics in order to manage, in order to develop some sorts of management practices in order to protect these critical zones. So therefore, it is very important. So some of the critical zones ecosystems are rivers, estuaries, mangroves, and seagrasses. I'm sure that you are all aware of estuaries, mangroves. Estuaries, mangroves are very highly fertile lands, ecosystems on this earth system that supports enormous amount of biomass. I'm going to cover these two things when I touch upon case studies. Okay, so here, this slide, I want to give you a fundamental information about the ecosystem. What is ecosystem? Ecosystem is a combination of biotic and abiotic aspects. So generally, the ecosystem is formed by an interaction of a community of organisms with their environment. So if in one place, if there are certain uh, organisms are there, either it could be plant community or animal community. So the plant community and animal community is having a close interaction with their surroundings. So that is called ecosystem. So in the ecosystem, you can find energy flow and food chains. These works together, and all ecosystems, as I said earlier, all ecosystems have animals, plants, insects, and all these biological elements have their natural habitat, and all these biological elements have constantly having an interaction with the natural habitat. At any time, if you step outside of your home or your community, you can find the natural ecosystem. For example, since you are in the VIT Andhra Pradesh institution is lying on the river ecosystem, if you cross the river, Krishna River, you can find a enormous amount of aquatic plants and aquatic biota within this Krishna River stream, and that is one of the very critical zone, and it has been impacted by human communities tremendously over a period of time. So what are the major components of the ecosystem? What are the factors that affects the ecosystem structure and function? So broadly, there are two factors. These two factors regulate the ecosystem structure and function. One is the abiotic factor, and second one is the biotic factor. Abiotic factors are non-living agents. These are broadly air, water, light, soil, nutrients, temperature, salinity, humidity, wind, and the list will go on. So, and what are the biotic factors? Biotic factors are broadly a living organisms existing in a particular ecosystem. It could be plants, it could be animals, microbes, humans, and the interaction between the animals. These are largely competition and predation, symbiosis. Symbiosis could be two types. Either it could be mutualistic association or parasitic association, and some microbes or as you know that microbes are different types. Some are very deadly dangerous to humans, not only the humans but also animals, and some are very very useful. So some of the disease causing agents like the bacteria and virus. So the biotic factors having a strong influence on, sorry, abiotic factors having a strong influence on biotic factor sustainability. So if there is any changes in the abiotic factors, then that has a linear impact or direct impact on the biotic community within a ecosystem. So it is very very important to understand the basic structure and function of the ecosystem, um, to study the various abiotic factors influence on the biotic environment, and what are the downstream impacts of the biotic environment changes. It is very important. Okay, so this slide is mainly gives an idea about ecotone. What is ecotone? Ecotone is a cross boundary between two ecosystems. As we all know that um, the river the land may not be land everywhere. So sometimes the land will meet with the water and the transitionary zone. Here is the transitional ecosystem. It's a marshland. So that means this land has a future a complex features of both land ecosystem, at the same time the aquatic ecosystem. So here you see this the soil, and you can find some of the aquatic animals here, mainly amphibians and some turtles and some sea grasses and all sorts of amphibian features you can find in this ecotone. Now, so ecotone is a very highly fertile, and ecotone is a very very susceptible to all types of changes that happens to the biotic environment and abiotic factors. Okay, so ecosystem energy flow and food chain. These two concepts, energy flow and food chain, is a very very important um, for the ecosystem structure and function understanding. You know, in any ecosystem, there are two types of organisms. One is producers, and second one is the consumer. Producers are generally autotrophs. They take carbon dioxide, and with the help of solar light, that is a UV radiation, and convert carbon dioxide into glucose molecule, which is called photosynthesis. And this photosynthesis happens during the daytime. In the nighttime, the synthesized glucose molecule gets disintegrated, and the energy will be converted. That glucose converts into energy, and carbon dioxide released back to the atmosphere. And that energy is being used by producers, mainly the autotrophs, the plants, for their biological activity. And also you see the consumers. These are all heterotrophs. These heterotrophs get the organic molecules from autotrophs by consumption. So there are different types of consumers in the ecosystem. So we need to understand what are all the different types of producers and consumers in the ecosystems that are impacting the ecological structure and function. So based on their dynamic interactions, we need to have some kind of a strategy for the management purpose. So in order to develop a strategy, we need to understand what is the food chain that is happening within a particular ecosystem. So what is the food chain? Food chain is a linear sequential actions of an organisms that happens within a particular ecosystem, through which nutrients and energy is passed from one organisms to the another organism. At a particular level, if any organisms are set up at a particular level, that is called trophic level. So here, this is the autotrophs, and this is the autotrophs, and this is the grasshopper. This is the second. These are the grass-eating animals, and then followed by the complexity of the organisms will increase along the food chain. So this is the first level of trophic level, and this is the second trophic level, and third, fourth trophic level. If you look at this, the linear progression, you can see that the complexity of the trophic structure is getting increased in a linear way. And at the same time, if you look at the mass of the biomass composition and structure, the biomass composition structure is also getting decreased along the food chain. So in a food chain, each organism occupies a different trophic level, and that is being defined by how many energy transfers separated from the basic input of the chain. So first we need to define the what type of food chain is happening at a particular ecosystem, and what are the how many trophic levels are there, and what is the composition of the trophic level is very important to understand the ecosystem structure and function. And in any ecosystem, the food chain, only one food chain doesn't exist. A large number of food chains exist, and all these food chains are dynamically interacted with each other. So it makes a complex web that is called food web. So food web consists of many interconnected food chains and are more realistic representation of consumption and the relationship in ecosystems. So energy transfer between trophic levels is inefficient. That means one trophic level, the energy transfer from one trophic level to the another trophic level, if you do the mass balance equation, you see that, for example, here, if it is whatever the energy that is produced from the autotrophs, not 100% that is transmitted to the first trophic level. So hardly 10 to 15% of this total energy is transmitted to the first trophic level, and an enormous amount of energy is being wasted when the energy is being transported from one trophic level to the another trophic level. So this efficiency limits the length of the food chain. Okay, this is very important, the energy flow and food chain. Okay, so this slides is extracted from Max Planck Institute of Meteorology, and this slide high-level interactions between all components that exist within the Earth system. So here you have the atmosphere and ocean, and this is a land ecosystem, and this is a cryosphere. Cryosphere means ice environment. So if you look at here, all these four Earth components have dynamically interacted with each other for various things, for trace gases and particulate exchange between the oceans and atmosphere, and also the heat and water. And similarly, the interaction between oceans and cryosphere is for heat and water, and for the land ecosystems and the cryosphere is for the heat purpose, and for the atmosphere and land surface is for water and some trace gases. And similarly, the atmosphere and the cryosphere is for water in the form of snow, and also the trace gases. So, and if you can find here in between, in the center, you have the humans. The humans requires large number of resources from all these four components. For example, fisheries and forest and land use and industry and water. These are all very, very important for human sustenance. So the human ecosystem requires components from all these Earth system subcomponents in order to maintain their sustainability. So the humans should use these systems very diligently without altering their structure and function for the ecosystem sustainability. But that is not happening right now. We are overwhelmingly damaging these ecosystems for our use. So that is the problem right now the humans are having from this. Either it may be from atmosphere or ocean or cryosphere. So that means if you change, if you alter, if you overuse these resources, you will be having, you have to pay price by various things. And we are constantly hitting these typhoons. In India, cyclones, and in USA we get hurricanes. These hurricanes and cyclones, the intensity of hurricanes and cyclones are being increased magnitudely in the recent past. These are mainly due to human-induced carbon dioxide released into the atmosphere, and that increases the temperature and that alters the ocean dynamics, ocean hydrodynamics. That changes in the ocean hydrodynamics will alters the pressure system and also the temperature system within the ocean environment, and that is the main reason for resulting high climate change events like cyclones and typhoons that are having a very negative impact on human livelihood. So we should be very, very careful about when we are using these earth resources. Okay, so now we are slowly moving into the we covered about what is ecosystem, what is earth ecosystem, and we are going into the biogeochemical cycles. So biogeochemical cycles is a very, very important for the earth ecosystem in order to maintain the equilibrium, the material equilibrium, the energy equilibrium within the all components of ecosystem components. So this is basically called as a substance turnover or cycling of the substance is called biogeochemical cycles, and it is the pathway by which a chemical substance moves through biotic layer, that is the biosphere, and abiotic layer of the earth. Abiotic layer mainly lithosphere, atmosphere, and hydrosphere. So there is a constant transfer of chemical substance between biosphere and abiotic sphere. That is called biogeochemical cycles. So there are various types of biogeochemical cycles. One is the rock cycle. Rock cycle mainly includes carbon, hydrogen, mercury, nitrogen, oxygen, phosphorus, selenium, sulfur, and various micronutrients and molecular cycles for water and silica. So rock is the fundamental components for the biogeochemical cycles. So, and the second type is human induced cycles. What is human induced cycles? The humans, we manufactured various synthetic components. For example, polychlorinated biphenyl, PCBs. PCBs are quite extensively used nowadays. Okay, but these in some places, in some cycles, there are reservoirs where a substance remains in a particular system, particular place for some significant time period. So these PCBs that stays in the environment for large period of time. So they have their degradation, their turnover rate is very, very long. So we have to be very careful when we are using these elements, and if we are not sure about whether this element or this component is having a very long period of retention time within the earth system, so we should make some strategies to recycle those things. rather than dumping into the open environment. So the polythene covers is the biggest problem that India, not only India and other developing nations are currently having, and it is having a large, tremendous impact on water ecosystems and at the same time some of the biological features as well. Okay, here I would like to give you a brief presentation about the various cycles. The first one is the hydrological cycle. So what is a hydrological cycle? Hydrological cycle is a transport of water between the earth components like ocean to it gets evaporated and condensed, and then cloud formation, and then the clouds returns the water in the form of precipitation. The precipitation maybe is the solid precipitation or liquid precipitation. Solid precipitation means snowing, liquid precipitation is raining, then storm water, and then infiltration into the ground system, and then freshwater storage, and then groundwater seepage into the adjacent water bodies. And these are all dynamically interacted with each other. So this hydrological cycle is very important, and this is the factor regulating all biotic components on the earth system. Without water, there is no life. So we have to be very, very careful and very judicious while using the water. And second is the carbon cycle, which is very important. I am sure you guys have heard about this, the carbon movement across the various components of the earth system in many, many ways. Like humans are the one of the main factors. We are altering this carbon cycle tremendously. So in terms of fossil fuel burning and changing the land use, if you dig 1 acre of the land and convert the forest land into various things, maybe for the household purpose or maybe for the agricultural purpose, and 1 acre destruction, that will leads to emit a huge amount of carbon dioxide into the atmosphere. Then once the carbon dioxide is emitted into the atmosphere and it interacts with the water within the water vapor within the atmosphere, and it converts into the acidic form, then it precipitates back to the water on the earth, maybe in the ocean or in the river streams, and this acidification will impact the soil structure and also the water chemistry in the aquatic streams and also in the ocean and estuarine environments. So that acidification mainly not only alters the soil structure but also impacts the some of the microbial organization structure in the oceans, which is very, very dangerous for the ecological equilibrium. So we should be we have to study this carbon cycle in and out to visualize the impacts of carbon dioxide impact on these ecosystems components. Similarly, this is the nitrogen cycle. Nitrogen cycle broadly called as a gaseous cycle because a huge amount of nitrogen gas in the atmosphere. So due to this natural process, the atmospheric nitrogen gets fixed and into the and that returns to the soil, and through the ammonification and the nitrifying bacteria that atmospherically fix the ammonia in the nitrogen in the form of ammonia gets converted into the NO3, and that will be useful for the plants. And then some of the denitrifying bacteria plays a key role here that converts NO3 into nitrogen in the form of denitrification. And this is the general pathway that is being happening right now to cycle the nitrogen across all the major components of the ecosystem. And this is a sulfur cycle. Yeah, this sulfur cycle is also important along with this nitrogen and sulfur, nitrogen and carbon, because if you look at one of the major reason for understanding this sulfur cycle is the sulfur impact on the ecosystem is also very important along with this carbon and nitrogen. If you look at this, the beauty of the Taj Mahal, the beauty of the Taj Mahal is getting degraded over a period of time. What is the reason? There is a petroleum refinery company which is lying very close to the Taj Mahal in Madurai, in Madura. So that petroleum refinery emits a huge amount of the sulfur dioxide into the atmosphere. So when there is a rain, that sulfur dioxide, the sulfur dioxide reacts with the water and it precipitates in the form of H2 sulfuric acid. Taj Mahal mainly contains the marble, calcium carbonate. This calcium carbonate reacts with the sulfur dioxide and it gets eroded. So understanding the sulfur, not only the sulfur, maybe the cadmium, chromium, and potassium, and these are all very important. Some are having impacts on our antics, and some are having an impacts on our biological things, and some are having an impacts on the microbial organization structure within the oceanic environment, and some are having an impact directly on our health, on our human health. So therefore, it is very important to study and understand the chemical equilibrium of these major and micro element transportation across all the earth system subcomponents. So understanding biogeochemical structure, cycling pattern is important. Okay, so we talked about ecosystem structure and function, and food web, food chain, energy transfer, ecotone, and biogeochemical cycles. The next, I'm going to touch upon human impacts on the coastal ecosystem. Excuse me, just 1 minute. Okay, the climate change impact on the Earth system. If you look at here, over a period of time, the carbon dioxide levels in an atmosphere has been increasing in a linear way. Okay, and at the same time, the global temperatures are also increasing at the linear way. Then PCO2 levels, the carbon dioxide levels and temperatures, and pH is increasing linear way in the oceans, and pH, which is a very critical water quality parameter, that is getting decreased. That means it is moving towards acidic, which is very dangerous to the aquatic biota. So it is very important to understand. So rapid increases in the fossil fuel burning leads to the increased levels of carbon dioxide, not only in the atmosphere, but also in the oceanic environment as well. This has a direct impact on the aquatic structure, mainly on the coastal and ocean systems. As we know that dissolution of carbon dioxide in the water forms carbonic acid, which causes reduction in the pH, and the linear decrease in the water pH in marine waters have a very serious impact on the biological systems, largely coral reefs and diatoms. Diatoms mainly contains the silica, SiO2, and the coral reefs mainly contains this calcium carbonate or calcium crystals. So if there is a pH slight change in the pH, maybe changing in a 0.01 or 0.002 pH scale on the pH scale, and that slight change will have a tremendous impact, negative impact on the diatom structure, cell structure, and also on the coral cell structure. And that leads to the mineralization of their shell and increases the vulnerability of the chloral bleaching. So chloral bleaching means if there is a pH changes towards the acidic, and that acidic water uh, removes the component from the coral structure, chloral shell or diatom shell. So that is called bleaching, and you can find coral bleaching um, along the Indian coastal waters, mainly in the Lakshadweep Union Territory areas. And also you can find some of these coral reef degradation due to the human induced activities in Kerala region. And also it has a significant impact on the seagrass environment as well. So it is very important to study the climate change impacts on the earth ecosystem, and we have been working on this, and a large number of studies have been taken place across the world from the various uh, parts of the things. For example, in India, there is one research institution in Pune called Indian Institute of Tropical Meteorology. That institute is mainly studying the climate change impact on the Indian monsoon. So if there is any changes in the Indian monsoon structure, and any that has a direct impact on the Indian economy. So Indian economy is mainly based on agriculture. If there is any sudden shift in the agricultural, and that is having a very direct trickle down impact on um, society. So that means we have to follow some of the guidance given by the scientists to understand the weather process, weather pattern, what type of crop plantation is good for a particular season. So the IITM scientist and also some folks from INCOIS Hyderabad, and there is a one institution in Chennai affiliated to Anna University. So these are all collaboratively working together to develop an integrated Earth system model for India. So that is having a by following those predictions and those guidelines is very important. We should make use of those products. Okay. So one of the direct direct human change impact on human disturbances impact on global Earth system is carbon dioxide release, and that increases the temperature and pH in the water. And another impact is nitrogen exports from land to the water. Land to the water means land to the freshwater streams, and ultimately it is dumping into the global ocean. If you look at this graphic, okay, you can find a huge amount of nitrogen is being discharged into the global waters from land, or mainly coming from hugely populated regions like India, China, and some parts of Europe, and from United States. And some of the things we do not have the data, but this is a kind of a pretty good global distribution, and some areas are having a very less amount of nitrogen discharge into the water. What is the reason? Because population. If there is a huge population growth happens, then that requires application of nitrogen fertilizers to increase the food production, then extensive use of nitrogen in the croplands that leads to discharge a huge amount of dissolved nitrogen. The dissolved nitrogen could be either it is inorganic form or organic form. and that huge amount are leading into the as a discharge into the global ocean, and that impacts the ocean aquatic structure. And if there is a huge nitrogen discharge, and automatically there is a pollution, that pollution leads to the various uh, things like hypoxia or anoxia. I'm going to cover hypoxia or anoxia uh, after some time. If you look at this below graph, this bar chart mainly tells you that how much amount of nitrogen is being discharged in the year 1990 and how much amount of nitrogen is predicted that is going to be discharged by 2050 from the various parts of the world. If you look at here, I mean, in all parts, there is a tremendous increase from 1990 to 2050. But if you look at the Asia, East Asia and South Asia growth, I mean, the increase is very, very high. So this is mainly because of human demand for nitrogen for agricultural purpose. So we have to be very, very careful in using this nitrogen fertilizer in the agricultural land in order to protect our water bodies. Yeah, the India. If you look at India every year it is releasing approximately around close to 500 kilos of nitrogen per kilometer watershed per year. It is a very, very high amount. So that's why if you look at most of the Indian water systems are highly polluted, and you can find all sorts of pathogenic bacteria in water. And if you see the nearby water system to the VIT AP institution is the Krishna River. If you look at, I mean, during this winter time, in the rainy time, the monsoon time, I personally noticed a huge amount of water waste is being dumped into the Krishna River, and uh, that is the main cause of water quality degradation. And you know, in the water bodies, this nitrogen inputs are two types. One is the point input, and second one is the non-point input. Point input means it is highly regulated. For example, if you have the municipal wastewater treatment plant, and once the water gets treated, once all the human drainage water, once it get treated, and that treated water is being dumped into the river stream. So you know how much amount of treated drainage water are you are dumping into the water stream. So that is called point source. And non-point source, it is very difficult to gauge the non-point sources to estimate how much amount of nutrient is being discharged into the water bodies. For example, the agricultural seepage. Once you put a huge amount of nitrogen on the agricultural land, and that nitrogen in the form of liquid reaches into the groundwater, and then the groundwater seepage into the adjacent water bodies, that increases the nitrogen concentration in the stream. And we cannot gauge, we cannot monitor how much amount of nitrogen. We can do that, but it is very difficult to maintain a real-time monitoring system to estimate the amount of nitrogen is being discharged through the groundwater discharge into the agricultural to the adjacent water bodies. So it is very easy to manage the point sources, but it is very difficult to manage the non-point sources. Therefore, we have to have some kind of a management strategies in minimizing the application of fertilizers. Whenever we need, we have to use the fertilizer in a limited quantity based upon the acreage and what type of plant is being planted in a particular area. So all sorts of management strategies should be taken care of while doing any agricultural business. Okay. This slide will give you an idea about coastal water oxygen minimum zones. As we are already know that oxygen, along with the water, oxygen is very, very important for life systems. If there is no oxygen, there is no life. But you can see that various places across the globe, the coastal areas, the oxygen concentration is less than 5 ppm, milligram per liter, 5 milligrams per liter. And if there is any low amount of oxygen in these systems, these are called hypoxic systems. If the oxygen concentration is less than 2 milligram per liter, that is called anoxic systems. In the hypoxic environment, some sorts of animals could survive, but whereas in anoxic environment, there is no life. You can see there is a huge areas along the coast has very low amount of oxygen. What is the reason? The reason is nutrient pollution, human impact, and climate change. Temperatures, the atmospheric temperature is getting increased over a period of time. So we have to be very careful when we are using our earth resources. Okay, let's come to the Indian mangroves. This is one of the study that I conducted sometime in almost 10 years ago, 2011. I collected the data from various mangrove ecosystems in India, Sundarbans, Sundarbans in Tamil Nadu, Bhitarkanika in Orissa, Koringa in Andhra, mainly in the Godavari Delta, and Pichavaram in Tamil Nadu. Sorry, Sundarban in West Bengal, and Mangalavanam in Kerala. So these are all very highly fertile and highly vulnerable mangrove ecosystems in India. So I collected the data, the long-term data, basically the inorganic nutrient data, nitrogen, phosphorus, and silica, and I baselined these nutrient ratios with respect to the Rietveld ratio. The Rietveld ratio is the molar element ratio between carbon, nitrogen, phosphorus in the phytoplankton is the 106:16:1, and also the silica nitrogen is the 16:16 or 1:1. And these Rietveld ratios are highly useful to analyze the current status of ecosystems. And what I found here is all Indian mangroves have been impacted by the human nutrient pollution. So therefore, we have to have a strategic plan in managing these mangrove ecosystems, not only for ourselves, for our future purpose. So that is called sustainable development. So strong sustainable management practices are needed to manage these coastal ecosystems. You can find this article in the Earth and Environmental Sciences Journal from 2011. Okay. The first case study here is the Pichavaram mangrove from Tamil Nadu. This Pichavaram mangrove is in the river Kaveri Delta. It is very close to the Chidambaram town in the Kadalur district. If you look at the land use pattern between 1995 and 2003, I have the latest data as well. I need to analyze the data. But if you look at the land use pattern change between 1995 and 2003, there is a huge changes. There is a huge changes. And if you look at this this plot, so there is a tremendous increase in the dense mangroves after 2000. But from 1991 to 2000, the mangrove density has decreased. The reason is a large amount of mangrove area has been distracted by the nearby villagers and converted the mangrove area for agricultural purpose. Agricultural in the sense for the paddy field, and some area, some mangrove area was used for fishing purpose and other things. So that badly destructed the structure. And this mangrove is a sandwiched mangrove. What I mean the sandwiched mangrove means, this is the mangrove core area, but this mangrove zone is in between the two estuaries. The upstream is called the Velar estuary and the downstream is called the Coloran estuary. And there is only one freshwater source to this mangrove. It is called Upanar. But the water flow in the Upanar river is highly regulated, because this water somewhere here in the upstream has been diverted for the agricultural purpose. So the water input has been tremendously reduced to the mangroves. That is one of the reasons that leading to the hypoxic conditions in the mangrove ecosystem. So if you look at this one, decadal nutrient trends in the Pitchavaram. From 78 to 87, the nutrient increase is pretty much okay, but there is a big spike. 87, 89 to 98 and 99. So this is the problem area, problem time zone. So this is mainly because of converting mangrove area for the agricultural purpose. Once they use that land for an agricultural or for the fishing purpose, then when the season is over and they are dumping that water directly into the mangroves. So that destructed the ecological ecosystem chemistry of the mangroves, and that leads to the hypoxic conditions within the mangrove ecozone, which is not good for the Pitchavaram ecosystem structure. And this slide will give an idea about annual variability of the dissolved nutrients and oxygen and chlorophyll, and this gives a sense about in which season the nitrogen or phosphorus or silica or ammonia is getting changed over a period of time. And if you look at this oxygen is starting from July to the June. There is a very seasonal trend here, and in the winter time you have the high oxygen levels. In the summertime you have the low oxygen levels. As I said here is that if there is any low oxygen that causes the hypoxic and anoxic conditions, there are certain places in the Pitchavaram mangroves you can find these hypoxic areas. And the reason for a high amount of oxygen in winter time is when there is a huge amount of water that comes from the nearby freshwater streams, that leads to the dissolution of atmospheric oxygen into the water, and that elevates the oxygen levels in water, and that has a direct impact. The nutrients structure has a direct impact on the biological structure. Here the biological structure, we are using the chlorophyll as a parameter to understand the biological structure. And you have the very seasonal behavior of the biological structure here in terms of the chlorophyll in a Pitchavaram water. Okay, this is a nutrient stoichiometry. As I said earlier that the Redfield ratio, carbon, nitrogen, phosphorus and silica has been used as a tool to understand the human impacts on aquatic bodies. So in most of the things, if you look at here, the Redfield ratio for silica and nitrogen is 1:1. In monsoon time, it is pretty much okay. Okay, but in case of summer, it is impacted very badly. Similarly, in case of the nitrogen phosphorus ratio, the standard is a 16:1. In both seasons, summer and monsoon, it is impacted very badly. Again, this huge amount of nitrogen or phosphorus is being discharged into the water from the nearby activities, nearby watershed activities, and also converting area for these developmental activities. So, but in the recent past, what I understand by checking with my colleagues in the Annamala University, and also there is an institution very close by to the Speechwara mangroves is Center for Advanced Studies in Marine Biology in Annamala University. What I understand from them is they started a very serious management strategies. They implemented the strategies in controlling mangrove destruction by the adjacent villagers, and they have the patrolling facilities have been started there. That has lead to improve the water quality, and this kind of realizations happens after 2004 tsunami. So wherever there is a huge mangrove plants and those areas are not impacted or not impacted by these storm surges created by Indian Ocean tsunami in 2004. So that was a starting point to realize the importance of the mangroves. So some of the villagers are also coming forward, contributing to the mangrove regeneration activities. Okay. Just I want to check with you. Am I audible?
Yes, no problem.
Okay. This is all about the Pichwaram, and the second case study here I would like to present here is the Chesapeake Bay. Chesapeake Bay is on the east coast of United States, and which is a very critical environment that is regulating the Mideastern United States atmospheric interactions and also environment. And similar to the Pichwaram, and this Chesapeake Bay is also very fertile, and it has a large amount of seaweeds, zooplankton, and oysters, blue crab, and fish, and egret. So the Maryland blue crab is a very famous here, and there is a huge amount of blue crabs have been harvested every year for the commercial purpose. If you look at some of the graphics here, the first graphic mainly explains the historical distribution of forest cover in the Chesapeake Bay watershed. Starting from 1650, we have the data. That is the beauty here, is that we have a very long-term data that is available for this ecosystem. And if you look at here, there is a very linear reduction in the forest cover starting from 1650 to 1900, and then slowly it's getting increased until 1960, and then again it is decreased. And that has a very direct relationship with the population growth in the Chesapeake Bay area. So these two slides clearly indicates that this Chesapeake Bay is being pressurized by humans for their benefit. So as a part of the project, as an interdisciplinary project that I worked at the University of Maryland to develop an integrated Earth system model for Chesapeake Bay for the management purpose, we studied the water quality of the Chesapeake Bay. So what we did, we collected a long-term data for almost 20 years data, starting from 1985 to the near term, to analyze their trends. And we have the data from almost all points of the Chesapeake Bay, and then we interpolated those things on the Chesapeake Bay grid to see that seasonal variations. And if you, hopefully you are seeing there's some kind of a changes in the colors. So the changes in the colors in the nitrogen graphic and also nitrate and then phosphate graphics are mainly due to the various, you can find the red zone somewhere. Yeah, here the red zone in the phosphorus, and also the nitrogen in the somewhere in the upper zone. So these are all the places where these are the point sources. A huge amount of the nitrogen and the phosphorus being discharged into the Chesapeake Bay from the nearby water bodies. Here there is a river called Susquehanna River, and this is a river called Potomac, and these are the Rappahannock and Patuxent, and these are the small rivers. And these small rivers discharges a huge amount of nutrients into the water body, the Chesapeake Bay, and that is the main factor. Is Chesapeake Bay is getting polluted, and that leads to the formation of hypoxic and anoxic zones in this area. And we studied the relationship between the freshwater discharge on the nutrient dynamics, and we have seen that some place there is a statistically significant spike in these areas. These spikes are mainly due to freshwater induced distribution of nutrients into this water body. And we have seen the direct relationship between total discharge and the Susquehanna discharge. That means Susquehanna is the main point source for this water body nutrient chemistry distribution. And we also studied the interannual variability of the chlorophyll. And not only in this ecosystem, in any ecosystem, if you look at any extreme climate event, before event and after event, the biological structure of the aquatic ecosystem will be highly distributed and highly disturbed, mainly because these climate events that brings a huge amount of dissolved inorganic and nitrogen, inorganic and organic and particulate nutrients across the landforms, and that dumped into the water, and that becomes mineralized, and then is highly accessible to the biological components. So that gets polluted, eutrophication, and all sorts of things will lead to the increase the chlorophyll concentration. Here we have this post Isabel and then pre Isabel sometime in 2003 in the Chesapeake area. So immediately 1 month before this hurricane season, we collected the water quality data, mainly the chlorophyll. If you look at the chlorophyll concentration in the pre Isabel time is very low. It's a hardly, most of the ecosystem has around 5 to 7 microgram per liter. But immediately after the post Isabel, this water quality data was collected 1 week after the hurricane season. Then we see that we found it. There is a huge spikes across the ecosystem. So in order to develop the sustainable management practices, we have to understand these extreme climate change events and then how to manage the ecosystem during these extreme climate events times. So again, this nutrient stoichiometry, as I said earlier, this nitrogen and phosphorus ratio is very important and is a significant tool to understand the ecosystem structure. And here I don't want to go into these details, and this a very detailed discussion is needed. It would take a long time. Okay. The next component I want to touch upon is hypoxia. This hypoxia is low amount of oxygen in the water body, and this low amount of oxygen in the water body that leads to the biological degradation and increasing the reduction activity in the water system. So that reduction activity having a very tremendous negative impact on the water body ecosystem. So we need to study these hypoxic conditions, and we need to understand what are the driving forces for these hypoxic conditions. So mainly the hypoxic conditions are mainly due to global warming and increased nutrient concentrations from land to the water. And we have studied some long-term analysis here. We found that the oxygen levels are gradually decreasing over a period of time, leading to the hypoxic and anoxic ranges, and also the temperature is water temperature is increased. That leads to the thermification of the water is happening in the Chesapeake Bay. And we predicted that by 2030 there will be a change in the discharge, and there is a change in the salinity structure will happen very significantly. That leads to the increasing the hypoxic conditions and anoxic conditions in the water. So based on this, we developed the model called CBFS, Chesapeake Bay Forecast System. This includes the three sub-modeling systems like weather research forecast. This is the atmospheric model, and SWOT, soil water assessment tool, is the land water modeling system, and the ROMS is the hydrological model. We coupled all this model to come up with a model to predict the oxygen concentrations in the Chesapeake Bay, real-time oxygen concentrations, by using temperature, salinity, nitrogen, and phosphorus. And we validated the model, and we verified the model with the various statistics. And finally, we are regularly predicting this near time and also the seasonal forecast. Real time, near time means the 14-day forecast, and seasonal forecast means for 3 months. And these are being currently used by NOAA, which is a federal agency in the United States for the management of this ecosystem. And we also identified some of the coastal deoxygenation zones along the across the India. And one of the things we found out is the Indian Sundarban mangroves. Here, okay, its oxygen levels are increasing over a period of time 1 micromolar liter per year, and temperature is also getting increased by 0.025. But it looks like it is a very small number, but this small number has a significant impact on the water structure. Yep, these are all things I have for you guys today. Thank you so much. And any questions?
So there are a few questions from the student side.
Sure.
Can you access the chat, or else I can copy the messages in the chat option?
Chat. Show conversation.
Or else I can read that one.
Yeah, please.
So I heard news that the ice in Antarctica is going on melting and going into the sea. If it continues like that, what will happen? Does the water level of sea increases? What will happen to the earth, and why it is happening?
Okay, it's a very good question, and it's a very contemporary question. So yes, that is correct. The icebergs in Antarctica is getting melted over a period of time. The reason is a global climate change. It's increasing the carbon dioxide that leads to the temperature increase. The temperature increase leads to tremendous melting of icebergs in Antarctica. And the melting of the ice that leads to that increases the freshwater flow in the nearby water systems. So if there is a huge freshwater discharge, and what happens? The storms would happen. For example, if you look at some of the glaciers in India, in the Himalayan region, the glaciers is retreating over a period of time. So once the huge amount of the glaciers get retreated, and the freshwater system discharge in the Ganges is getting increased over a period of time, and sometimes you see that sudden storms happens, and that destructs the human settlements. Yes, and here the one question is that what does the water level in sea increases? If there is any increase in the sea level, what happens? That sea level increases, that leads to the subsurface groundwater discharge into the groundwater aquifers. So the groundwater aquifers get salinized, and then that salinized groundwater aquifers are not for human consumption. So these are all very interrelated negative impacts. So yes, it is getting bad over a period of time, but still there is a A lot of studies is happening right now by the various institutions like the Max Planck Institution in Germany, and also they have a good collaboration with IITM in Pune. Yeah, it is very important question, and thanks for asking.
And one more question. Uh, what kind of contributions for the nature can we make being a CSE student, computer science student, basically being from a technical background?
Okay, what kind of contributions? So irrespective of your affiliation, whether you are a CSE student or civil engineer or mechanical engineer or chemistry student, one should have a kind of a behavior, generous behavior towards the nature. Okay, one should not disturb the nature for unnecessary things. Like if you want to use any ecosystem, you should think about it a couple of times. Okay, what I'm doing here, is it really needed? If it is needed, how much amount I needed from this ecosystem? So one should have a kind of a judicious thinking while using that. Okay, if you want to use your knowledge in the nature, for example, the computer science student, okay, you have a very good technical background, coding skills, Java, C, C++, Python, okay, data mining, artificial intelligence. And these type of advanced technologies are very, very important in developing very dynamic ecosystem models. If you look at these type of models that I have presented, these are the basic models, but all these basic models require some background, backend infrastructure and coding. And backend infrastructure and coding are mainly being governed by technical folks like the computer science students, computer science graduates, electronics and communications, infrastructure, and all these types of knowledge is very, very important to develop and integrated sustainable ecological models to manage the environment. Okay.
And
Are
another,
Mhm.
sir, are there any positive things that human does for ecosystem?
Yes, there are. See, if there is a positive, if there is a negative things are there, means it doesn't mean that always it is a negative things. There are some positive things are also there. Okay, there are some places, I recently come across a very important thing. In there is a one village, I forgot the name of the village in Jagitiala district in Telangana. I was really surprised. They didn't dig a agricultural well in their agricultural land. What they were doing, they build a big pond and then they are harvesting all the river water and they are increasing the groundwater content by using various natural mechanisms. So they are using that water for their agricultural purpose. So they do not have any agricultural wells like the bore wells. So what they were talking is that the village panchayat sarpanch was saying that we are preserving the water for our future generations. That is a positive thing from humans. And along with that, there are many things. And at the same time, in other parts of Telangana, the groundwater has been miserably extracted from ground, and there is no water in some areas. So there are positive things are also there from humans and also negative things. Okay, there is a question that is Earth not enough for human race to live?
Yeah.
It depends. What type of earth you want? What type of water you want to drink? What type of food you want to eat? It all in your hand. Once you have a very clear vision, then you would know that what type of earth you want to sustain, not only for you, okay, for your dependents, for your fellow citizens. So one should be very, very careful while using those resources. Okay, does the effect of change in the chemical composition of the atmospheric affect the monsoon winds and the climate changes in India? Yes, yes. If you look at the recent study, or maybe I would suggest to go to the IITM Pune website to understand the recent changes in the Arabian Sea that is being impacted, that is having a very strong control over the Indian monsoon or Indian Ocean dynamics on the Indian monsoon. Yes, there is a direct impact. Chemical composition of the atmospheric is having an impact on the Indian monsoon. Okay, next question is, how do we make a huge impact on people and society to stop pollution and the degradation of the nature? Okay, it's a very good question. And in order to manage, in order to regulate the pollution, okay, every day you have to use water for your daily activities. Okay, some places without any treatment, all the human waste is directly dumped into the water. So that causes the pollution. So if you want to preserve the nature, what you need to do? Before dumping that waste to the nearby water bodies, you have to treat it. You have to remove all the things in terms of solids. Then only that fresh discharge should be dispatched into the or drained into the nearby water bodies. So you have to make all these steps in order to reduce the pollution load from land to the nearby water bodies. Okay, changes in the biogeochemical cycles in the continental water occasioned by the climate change. Correct. The recent studies clearly demonstrate that climate change induced temperature increase and also extreme climate events like storms, tsunami, hurricanes, typhoons, cyclones. Those climate events carries a huge amount of dissolved particulate, inorganic, organic, and all sorts of nutrients, microelements from land to the water that alters the biogeochemistry of aquatic system. Yes, that's correct. Okay, sir, there has been a rumor circulating over a period of years that if the glaciers continue to melt in the way as there are now, it is said that USA is the first country to be submerged in water. How true is this, and do we have any precautionary measures to prevent these consequences? I do not know where did you read this rumor. USA is not the first country to get submerged. Okay, and due to these various climate events, sea level rise, whenever there is a hurricane storms and or some nearby, the coastal zones are getting submerged, not only in US but also in India and everywhere. The first and foremost management strategies that should be implemented in order to avoid those things is to manage the population settlement along the coastal zone. And the government should come up with a policy that at least 100 meters away from the coastal areas, there should be no settlement. But in India, we have the Coastal Zone Management Action Plan, and there is a act also in the act is enacted by the Parliament for the Ministry of Environment and Forest Coastal Zone Management Act. But I do not know how to say. We are not following. Okay, those acts for ourselves, but we are not following. So we should follow the rules and regulations in order to protect ourselves from these events. How India can become less polluted country in the world and in many years as industries are developing faster for countries' development. Yes, we need industries. Okay, for the employment generation. At the same time, we have to have a strong procedures for the environmental management as well. So both should be complemented with each other in order to regulate the environmental pollution. So without industries, there will be no employment growth. So we need both, but at the same time, there should be a kind of an equilibrium should be established between these two entities in order to maintain the sustainable nature in the ecosystem by protecting the ecosystem components, at the same time providing essential needs to the human communities. What will happen if 100% transformation of energy takes place in food chain? If you look at the food chain, the energy transfer from one trophic level to the another trophic level at any time in any ecosystem, there is no 100% transformation. At least more than 50 to 60% energy is getting wasted. Only 10 to 20% of energy is being transferred from one trophic level to the subsequent higher trophic level. So there is no 100% transformation. It is not happening right now. What is the source for sulfur oxidizers when there is no sulfur reducers in the plant environment? The energy source for sulfur oxidizers is a H2S. Okay. For example, you have seen come across in India that many drainages in the winter time or mainly in the summer time, if you look in the open drainages is very common in Vijayawada. Okay, you can find that the black and bubbles. Do you know what is that? That is called sulfur reducers, anoxic sulfur reducing bacteria. So there is no oxygen in the drainage water, and that uses the H2S as the energy source rather than carbon dioxide, and that releases the sulfur dioxide, sulfur. And if you poke that bubble in the drainage water, you will feel rotten egg smell. That is the sulfur. Okay, I recently heard about light pollution. Do it affect the life? Yes, light pollution. You know, increasing chlorofluorocarbons, that has a direct impact on reduction in the ozone layer concentration in the stratosphere region of the atmosphere. If the ozone layer gets disrupted and the ultraviolet radiation is directly reached to the Earth system, and that has a very serious impacts on the human skin, that causes the skin cancer. Yes, there is a light pollution, and there is an impact on the microbial organization structure and also the plant, but still some work is going on. But yes, there is some negative impacts on not only on the humans but also the microbes. Okay, what is the difference between ecological niche and habitat? Habitat is the place where you are living, and niche is one of the small components of a habitat. How can we consider the impact of forest age when calculating the soil carbon emissions for the entire forest ecosystem? It is a very, very good question. It is a very research topic. Okay. There are a lot of tools out there to study this impact. And once you collect the samples from the forest, you have carbon dating. This carbon dating can be used to study what is the age. You can go back, and then by using that, you can estimate, you can recalibrate and re-estimate the carbon emissions from this forest ecosystem to understand how much amount of carbon dioxide being released due to converting that forest by deforestation at a particular region. Okay.
There are a few more questions, but I think we can wind up the sections.
Yeah,
here.
I mean, if you have any questions, then send me that. I will.
Of course, I will send.
Yeah. Whenever I have time, then I will reply. Yeah, thank you so much, and thanks for
And-
listening.
And I request Selvakumar sir to deliver the vote of thanks.
Am I audible?
Yeah, I can hear you.
I thank you for accepting our invitation and delivering a wonderful lecture on this particular topic. So, which is from the module 1 of our course, Environment and Ecosystem. So, you have nicely explained the complex interaction within the Earth system, mass and energy transfer in the food chain, food web, and various nutrient cycles, impact of human activity on coral ecosystem. Especially, you have highlighted the deteriorating coral reef and mangrove ecosystem, and you have given several examples of real life situations. So it's very important to us and the students community. So I thank you, sir. I thank you for accepting our invitation and delivering this talk. So at the outset, I thank our VC sir, Subhakar sir, for his vision of conducting this course as a series of innovative lectures rather than the traditional class teaching. So at the outset, I thank our Dean, Santanu Mandal sir, for his valuable suggestions in planning and executing this lecture series today. And I wholeheartedly thank our head of the department, Dr. R. Paramasivam, for facilitating the successful beginning of the lecture series. Thank you, sir. So I express my special thanks to the coordinator, Dr. Sabil sir, and all other faculty members of the department for inviting the external speaker and also organizing the event in a successful manner. So all of you have done wonderful job in conducting the event successful. We need your continuous support in the future lecture series that is going to come up. And finally, I thank our student participants for attending and being attentive during the lecture. So I thank you all for participating in this event. Thank you.
Thank you. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Bye.
Thank you, sir.
I'm hanging up. Bye.
Thank you.
Have a good day.
Yeah, you too.
Please.
You too, sir.
Bye, sir. Sabil sir, you can take attendance, other things.
Yeah, okay.